Hmm. Hello. Hello.
Good afternoon, sir.
Good afternoon. Shomnath has joined. Alok has joined. Okay. Let us wait.
Okay, sir.
Can you see this slides? Can you see the slides? Hello.
सर बोलिए बोलिए.
Can you see the slides?
हाँ सर एकदम क्लियर.
Okay. Okay. Okay.
सर रुकिए आने दीजिए सबको.
Let us wait for 1 minute. Then we will start the lecture. Alok, can you hear me? Hello, Alok.
Good afternoon, sir.
Good afternoon. 1, 2, 3, 4. Four of them. Okay. We'll wait for 1 minute. Then we will start our lecture. Should we start? Hello.
कर दीजिए सर कर दीजिए. टाइम जा रहा है.
Yes, sir.
कर दीजिए.
Good afternoon, sir.
Okay.
गुड आफ्टरनून ज्योतिर्मय.
So far, we have completed rolling contact bearings as well as sliding contact bearings. Now, two more topics are left. That is, one is flywheel and another one is pressure vessels. That is
Pressure
thin
vessel.
cylinder and thick cylinders. These two topics we can cover it very fast. Why? Because 50 to 60% of the portions already you have done in your previous semester in strength of materials. Well, see, thin cylinder portions you have done in strength of materials. Same things you have to do it again. And in flywheel, almost 60%, almost 60 to 60% you have done in dynamics of machine parts. Clear? Hello.
Okay, sir.
हाँ सर बोलिए आप कंटिन्यू कीजिए.
Fine. So what I will do is that I won't go in depth much because all these things already you have done in dynamics of machines. Again, you have to repeat. So I will just go to the important points, and after that I will start the numericals part. Fine. And for flywheel, you do one thing. I think in your official group, Sudipto sir has posted this book, Khurmi Gupta, Machine Design by Khurmi Gupta. Yes or no?
Yes, sir.
Fine.
हाँ
So
सर.
you can refer that same book for flywheel portion. Questions are good over there. Fine. No need to refer Bhandari because in Bhandari questions are a little bit complicated. Fine. So better you refer this same book, Machine Design by Khurmi Gupta for flywheel portion. Okay, let us start. First and foremost is you should know the definition of flywheel. This can come for 2 marks. Fine. Already you have studied in your dynamics of machine class. So I will not recapitulate it again. Next.
सर एक क्वेश्चन था सर.
हाँ बोलो. हेलो.
हाँ सर, पिछले वाले स्लाइडिंग बियरिंग में
हाँ.
आप एक क्वेश्चन दिया था ना सर, वहाँ पे एक होम का रूम टेम्परेचर दिया था और मतलब सर और बियरिंग का और एक टेम्परेचर दिया था.
हाँ.
वहाँ से सर टेम्परेचर के हिसाब से जो विस्कोसिटी हम लोगों को लेना है वो कैसे ले, वो थोड़ा समझ में नहीं आया. मतलब सर
मतलब जो मैंने लास्ट क्वेश्चन क्लास में कराया था.
हाँ सर, असाइनमेंट दिए थे ना सर, दो क्वेश्चन आपने, लास्ट वाला क्वेश्चन, सेकंड वाला.
You do one
हाँ
thing.
हाँ.
Whatever you feel that it is correct, you do it. Then send me the screenshots in my WhatsApp or mail me. Fine. I will see whatever you have done. If there is anything faulty, I will write down what is faulty, or if any correction is required, I will write down what all corrections is required.
ओके सर, ठीक है ठीक है.
So first and foremost is you should know what is the definition of flywheel. Fine. It can come for 2 marks. Then you can read it from the book. Fine. Then you should know the difference between flywheel and governor. Already, I think you have studied in your last semester. Yes or no?
Yes,
Hello.
sir.
Hello.
हाँ sir, हाँ sir.
Fine.
Yes,
So
sir.
you can easily read from the book. One is definition of flywheel. What is flywheel? Can you tell me?
Sir, it stores energy and it supplies the
It
energy
is
when
an
required.
energy storing device. In one line, if I say it is an energy storing device. Fine. Next, you should know that what is the difference between flywheel and governor. Clear?
Yes.
Hello.
Yes, sir.
Fine. Then you should know this one.
Yes, sir.
This term called coefficient of fluctuation of speed. Coefficient of fluctuation of speed. Fine.
हाँ ये पढ़ेगा.
It can come for 2 marks. What is coefficient of fluctuation of speed? It is nothing but the ratio of two quantity. Numerator portion will be the difference of maximum speed in RPM and the minimum speed in RPM during the cycle divided by N. What is this N? N is nothing but the mean speed in RPM. That is N1 plus N2 by 2. Clear?
Yes.
Fine. Again, if you write this speed in terms of omega, angular velocity, it will be omega 1 minus omega 2 divided by mean speed, that is omega. Mean speed omega will be omega 1 plus omega 2 by 2. You can write this coefficient of fluctuation of speed again in terms of linear speeds also. That is V1 minus V2 by V. V1 is what? Linear speed. Maximum linear speed. V2 is minimum linear speed divided by V. V is your mean linear speed. That is V1 plus V2 by 2. So you have to read the question accordingly and see which formula is applicable to calculate the value of CS. Any doubt?
No, sir.
Fine. Okay. Next, you should know this term called coefficient of steadiness. You should know this term called coefficient of steadiness. It is what? It is nothing but reciprocal of coefficient of fluctuation of speed. It is reciprocal of coefficient of fluctuation of speed. That means if you know the value of CS, take the reciprocal, that means 1 upon CS, that will give you the coefficient of steadiness. That means reciprocal of CS. If CS is N1 minus N2 by N, if I take the reciprocal, it will be N upon N1 minus N2. In terms of omega, it will be omega divided by omega 1 minus omega 2. In terms of linear speed, it will be V upon V1 minus V2. Again, you have to read the question. Accordingly, you have to decide which formula you have to use to calculate the value of coefficient of steadiness. Any doubt?
Right.
Fine. All these things you have already done in your dynamics of machine part. Fine. So I'm not going these things in detail. Okay. Next is fluctuation of energy. This is also important. It can come for 2 marks. Fluctuation of energy. Can anybody tell me what is fluctuation of energy in flywheel?
So the difference between the maximum energy stored and the minimum energy stored in a flywheel.
Yes. Fluctuation of energy. No, that is, you are telling maximum fluctuation of energy. Whatever you are telling the definition, that is maximum fluctuation.
Ha.
But if I talk about
Yes.
fluctuation of energy, I know that area under the torque versus crank angle theta diagram will give me the work done present in the flywheel. Yes or no? This you have already studied in the last semester. So if you are having
Yes,
a
sir.
mean torque line, see, this is turning moment T in y-axis. This is crank angle theta. Maximum, what can be the maximum crank angle theta? Maximum crank can rotate how
360.
many degree angle?
360.
360 degree angle, fine. So maximum crank angle can be 360 degree. Now, this is what? This A, B, C, D, E, F, this line A to F. This line is what? This line is
Mean
mean
torque
torque
line.
line. Mean torque line, fine. So if you plot a graph between turning moment T and crank angle theta, and if the graph comes out to be, means it will follow some sinusoidal pattern. That will depend. Say if your crank angle theta is 45 degree, what is your turning moment of the cylinder? What is your turning moment of the engine? If your crank angle theta is 180 degree, what is the turning moment you are getting from the engine? If you plot those values, you will get some sinusoidal kind of curve. Now, if you see above and below the mean torque line, this diagram is varying, yes or no? Hello?
Yes, sir.
Fine. So that means your torque, that means this T versus theta diagram, it is fluctuating. It is fluctuating above and below the mean torque line. These fluctuations give rise to this fluctuation of energy. Understood? What is fluctuation of energy? That is variation of T
Yes.
versus theta. That is fluctuation of T versus theta above and below the mean torque line throughout the complete rotation of crank angle is nothing but fluctuation of energy. Fine?
Okay, sir.
Any doubt?
No, sir.
Clear? Okay. So this diagram I can give for 2 marks in EndSem. That draw the turning moment diagram for single cylinder double acting steam engine. Indicate the different points. Then you should know how this diagram looks like. This is the mean torque line. This is y-axis is turning moment T. X-axis is crank angle theta. And definitely it will follow a sinusoidal curve. If you take different values of theta, you will get different values of T. And that relationship between T and theta is nothing but a sine curve. Fine. So this diagram I can ask for 2 marks. Clear? Should I move forward? Hello? Hello?
Yes, sir.
Okay. Next. This is very important, this diagram. This diagram is very important. What is this diagram? You have already done in dynamics of machine. That is turning moment diagram for 4-stroke internal combustion engine. If I am giving for 2 marks, you have to draw the diagram. But if I am giving for 5 marks, you have to explain what is happening in suction, what is happening in compression, what is happening in expansion as well as in exhaust. We know that in a 4-stroke IC engine, there are 4 working strokes. One is suction, another one is compression, third one is expansion. And we know that in expansion, we get the maximum power output. We get the maximum work done from the engine. So that's why this turning moment diagram, see, it is highest. Your peak is highest. And this dash 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 line represent your mean torque line. Mean torque line. That means above and below this mean torque line, fluctuation of this curve will give me the fluctuation of energy in this turning moment diagram of 4-stroke internal combustion engine. Is it clear? Hello?
Can you please repeat?
See, this diagram is very important. This diagram is what? Already you have studied in
सर
dynamics.
4-स्ट्रोक का बोल रहे हैं ना?
Sorry?
4-स्ट्रोक इंजन का बात कर रहे हैं ना?
Yes, 4-stroke engine. This is
हाँ,
turning
सही है,
moment
सही है,
diagram. Turning moment diagram for a 4-stroke internal combustion engine. Turning moment diagram is also known as T versus theta diagram. Theta is your crank angle. That means when crank has, that means initially valve get opened. When the valve get opened during the suction stroke, that means when crank has traveled 180-degree angle, fine, you will get such kind of curve. Again, during the compression stroke, once you compress, fine, again you will get some fluctuations. During the expansion stroke, we know that in expansion stroke, we get the maximum work done. So see, you are getting a positive loop, and that too, the peak is very high. And last one is your exhaust. And how these variations will depend, that you have to calculate. Say if theta is equal to 20 degree, T is say minus 10 Newton meter. Say when theta is equal to say 95 degree, T is say 14 Newton meter. Likewise, if you will do, you can plot this curve. You can plot this curve. And this dash 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 line represents the mean resisting torque line. Fluctuation of T versus theta diagram above and below this mean resisting torque line will give you your fluctuation of energy. This is the definition. Is it clear, this diagram? Hello.
Yes, sir. Yes.
So
Fine.
Clear.
how are we getting the values for different angle of theta?
I cannot hear you. If you can speak loud.
So how can we get the value for different angle of theta?
That you have to take the intervals. Say 0 degree, 40 degree, 80 degree. Likewise, 0 you can take in multiples of 10. You can take in multiples of 50 degree. Likewise.
Okay, okay, sir.
Likewise, you will get different values of t. Then you can get such kind of curve. Because I don't know what is the kind of curve. Once you do the experiment for different values of theta, how much is the work done you are getting, how much is the turning moment you are getting, then only you can plot such kind of curve. So normally by experiments it has been seen that you get such kind of curve for different values of theta. Clear?
Yes, sir.
Fine. So this
सर
curve is
क्योंकि
very
तो सर फ्लाईव्हील तो इंजन के साथ अटैच रहता है ना, तो
yes.
इंजन का जो
Curve is
वर्किंग इसी के
very
साथ होता है.
important. For 2 marks, only draw the diagram and show the different points. But for 5 marks, you have to give the explanation what I have given you just now. Fine. Okay. So here all drawings. Let us move forward. Next is C. Shomnath, you are telling about maximum fluctuation of energy. Maximum fluctuation of energy is the difference
sir, हाँ.
between the maximum energy and the minimum energy during that fluctuation period. Then only you will get that maximum fluctuation of energy. Yes or no?
Yes, sir.
When this T versus theta diagram is fluctuating on this mean torque line, difference between the maximum energy and the minimum energy will give you maximum fluctuation of energy. It will be very much clear when we solve the numerical part. See, it is written, the difference between the maximum and minimum energy is known as maximum fluctuation of energy. Clear? Okay. Let us move forward. Same thing. Yes. Calculation of maximum fluctuation of energy. This is important in numerical point of view. Calculation of maximum fluctuation of energy. Already you have done it. Say I am having this diagram. T versus theta diagram I am having. Fine. After experiments, it has been observed that T versus that is the pattern of T versus theta diagram is somewhat like this. Somewhat like this. And this AG line is which line? Can you tell me? AG line is which line? A to G horizontal line is which line?
So the mean torque.
AG line is nothing but the mean torque line. About this mean torque line, you are getting the fluctuations. Some fluctuations are positive in nature, some fluctuations are negative in nature. For the crank angle, and crank angle can vary maximum from 0 degree till 360 degree. Fine. So let us assume that let us mark all these points A, B, C, D, E, F, G, and area between A and B is small a1, between B and C is small a2, and so on till F to G is nothing but small a6. Now, if I want to calculate the maximum fluctuation of energy, what I will do is that I will calculate energy at each and every point of the cycle. That means at point A, B, C, D, E, F, and G. Let us find out. Now see, when the engine is in starting condition, definitely engine, when I start the engine, definitely engine is having some power. Yes or no? Power cannot be zero. Energy of the engine cannot be zero at the starting condition. Yes or no? Hello? Hello?
Yes, sir.
Yes, sir.
Energy cannot be zero at the start point. That means say energy at the start point A is nothing but E. Energy at B will be what? E plus, I am getting a positive loop, so it will be E plus A1, because area under this curve is nothing but work done, and area under this curve is nothing but energy also, so it will be E plus A1. Similarly, if I want to calculate energy at point C, it will be E plus A1 minus A2. Yes or no? Because that is negative. Assume that this is your zero line. From the zero line, this part is positive. From the zero line, this part is negative. So it will be E plus A1 minus A2. Yes or no? Hello? Hello?
Yes, sir. Yes, sir.
Fine. So it will be E plus A1 minus A2. Similarly, if I write the energy at point C, at point D, it will be E plus A1 minus A2 plus A3. Clear? If I write the energy at point E, it will be E plus A1 minus A2 plus A3 minus A4. C plus A1 minus A2 plus A3 minus A4. If I write the energy equation at F, it will be E plus A1 minus A2 plus A3 minus A4 plus A5. C. Last one is energy at G. It will be E plus A1 minus A2 plus A3 minus A4 plus A5 minus A6. And that will be
So that
equal to energy at the starting point, that is E. If it is not equal,
that
that
means
means somewhere you have did the mistake, because ultimately your cycle is starting from the initial point and finally at 360 degree your cycle is coming back to the initial point. So the initial point and the final point energy will always be same. If it is not same, that means somewhere you have did the mistake. Again you have to repeat the process. Is it clear?
yes. So that means whatever the
Yes, sir.
value
Yes,
is
sir.
above the
Yes,
mean
tell me.
torque line, it should be all positive.
Yes. Above the mean torque line, positive. Below the mean torque line, negative. That is the baseline.
Yeah.
Fine.
Yes, sir.
So now I want to calculate what? I want to calculate maximum fluctuation of energy. I know that maximum fluctuation of energy is nothing but the difference between the maximum energy and the minimum energy. So from this data, which data? From this data, find out which one is your maximum energy and find out which one is your minimum energy. That will depend from problem to problem. Let us, I am assuming that E plus A1. Say E plus A1 is my maximum energy after calculation I got, and this E plus A1 minus E plus A1 minus A2 plus A3 minus A4. That means this one, energy at E. This is minimum energy. This I am taking a random. That will depend from question to question. Fine. This is maximum, this is minimum. That means then I know by definition that maximum fluctuation of energy is what? Maximum energy minus minimum energy. That means E plus A1 minus times of in bracket E plus A1 minus A2 plus A3 minus A4. If you do it, you will get what? You will get your maximum fluctuation of energy. That means E cancel, plus A1 minus A1 cancel. You will get A2 because minus is plus A2, minus plus is minus A3, and minus is plus A4. So this is your maximum fluctuation of energy. This is the procedure by which I will calculate maximum fluctuation of energy of flywheel. Is it clear? Any doubt? Hello? Hello?
No, sir. No doubt.
Fine. So if I am asking the theory part that explain with diagram how to calculate maximum fluctuation of energy of the flywheel, you have to do this entire process. Fine. If I am asking the theory part, I can ask it for 5 marks, and then you have to do this entire process. Clear? Next.
Yes, sir.
Now let us move towards coefficient of fluctuation of energy. Now what is this coefficient of fluctuation of energy? It is nothing but maximum fluctuation of energy divided by work done per cycle. Already from this expression, you have got maximum fluctuation of energy. You will divide this maximum fluctuation of energy with work done per cycle. How you can calculate work done per cycle? That is area under this T theta diagram will give you the work done per cycle. Once you do that thing, you will get the value of CE. That is coefficient of fluctuation of energy. 2 marks, important. What do you mean by coefficient of fluctuation of energy? Clear? Hello? Hello?
Yes, sir. Yes.
Clear?
Yes, sir.
Very
Yes,
good.
sir.
Yes, sir. Yes, sir.
Now there are many processes. To calculate this work done per cycle. Process number one. Now that will depend from numerical to numerical. You have to see which all data is given to you. According to those data, what all things are suitable to you. Accordingly, you will use that formula. Fine. First way to calculate the work done cycle is what? T mean into theta. Already I have told you that is area under this T versus theta diagram. That means T into theta. Mean torque into theta will give you the work done. Fine. Theta is how much? Theta is nothing but 360 degree. That means 2 into pi. 2 into pi. But remember one thing. While calculating work done, you have to keep your theta in what? Radian or degree?
Radius.
So radian.
No, not in degree. While
In
constructing this
radian.
graph, you will calculate theta in terms of degree. But while solving, you have to
In
convert
radian.
this theta into radian always. That means you have to multiply it with pi by 180. Clear? So theta
Yes,
is
sir.
equal to 2 pi. See, theta will be 2 pi when it is a two-stroke internal combustion engine. Clear? Hello?
Sir.
Yes, sir.
Because
Yes.
in two-stroke engine,
360
because
degree.
suction and compression you are getting in one stroke, and expansion and exhaust you are getting in another stroke. So total stroke is how much?
Yes,
Total stroke is 2. That means total angle turn is 2 into pi. That is 360 degree. But in 4-stroke engine, you are getting 4 different stroke. One is suction,
Yes.
that is 180 degree. Again from 180 degree to 360 degree, you are getting compression. Again from 360 degree to next 180 degree. You are getting your expansion, and again from that next 180 degree to your 720 degree, you are getting your exhaust. So theta will be 4 pi. Is it clear? Hello?
Yes, sir.
Sir. Clear.
Sir,
Okay. So
yeah,
you read the question
we have to
accordingly.
take the angle in
Sorry?
radian, or we have to put directly
No.
4 pi.
No. 2. Yes. If you take pi is what? 22 by 7. 2 into 10, 22 by 7. Likewise you take. But if you are talking about degree, in 2-stroke engine, suction and compression you are getting in one stroke, expansion and exhaust you are getting in another stroke. So theta is 2 pi. But in 4-stroke internal combustion engine, you are getting 4 different strokes. One is suction, another one is compression, third one is expansion, fourth one is exhaust. And each stroke is taking 180 degree. And for each stroke, crank is turned by 180 degree. So theta will be 4 pi. Fine. Next. Second, and what is this T mean? I know that power is what? Torque into omega. So power is equal to mean torque into omega. Omega is 2 into pi into n by 60. So you will get T mean is equal to P into 60 divided by 2 pi n, where n is speed of the flywheel in RPM and omega is the angular speed of the flywheel. That is 2 pi n by 60. Clear how I calculated T mean? Hello?
Yes.
Fine.
Yes, sir.
Second way of calculating the work done per cycle is this expression. P into 60 divided by N. What is P? P is nothing but power. And what is this N? N is the number of working strokes per minute. Value of this N is capital N in case of steam engines and 2-stroke internal combustion engines. And in case of 4-stroke internal combustion engines, this value is capital N by 2. Capital N is what? Capital N is your RPM. Capital N is your RPM. And what is your small n? Small n is the number of working strokes engine can make per minute. If such things is given in the problem, then you can calculate the value of work done by this formula. That is power into 60 divided by that number of working stroke per minute. That will be equal to capital N for 2-stroke engine, and that will be equal to capital N by 2 for 4-stroke engine, where capital N is the RPM of the engine. Clear? Second way of calculating the work done per cycle. Fine. Next is energy stored in the flywheel. How much energy is stored in flywheel, that I need to derive, that I need to find out, that I will be requiring for my numerical part. How to get? See, this is my flywheel, cross section of my flywheel. This is called the rim of the flywheel. This is the arm of the flywheel, and this portion is the hub of the flywheel. What is capital R? Capital R is nothing but mean radius of the rim. Capital R is what? Capital R is mean radius of the rim. Now, what is M? Say M is the mass of the flywheel in kg. Small k. Small k is nothing but radius of gyration of flywheel. And small k is nothing but equal to R. Is equal to R. What is I? I is mass moment of inertia of the flywheel and is given by m into k square. Already you have studied this concept in mechanics. Mass moment of inertia
Yes,
is
sir. Radius of gyration.
m into k square. K is nothing but radius of gyration. Fine. And this k is nothing but equal to this radius, mean radius of the rim. What is n1, n2? N1 is the maximum speed of the flywheel and n2 is the minimum speed of the flywheel. What is omega 1 and omega 2? Omega 1 is the maximum angular speed of the flywheel in radian per second. Omega 2 is the minimum angular speed of the flywheel in radian per second. Now, what is this n? N is mean speed of the flywheel. That is nothing but maximum speed plus minimum speed divided by 2. That means n1 plus n2 by 2. Similarly, I can calculate mean angular speed of the flywheel. That is what? Maximum angular speed plus minimum angular speed divided by 2. So I can calculate the value of coefficient of fluctuation of speed, because by definition I know that coefficient of fluctuation of speed is difference between the maximum and minimum speed divided by mean speed. Same goes for angular speed also. Omega 1 minus omega 2 by omega. Now, since the flywheel is rotating continuously, if the flywheel is rotating continuously, then there will be some energy developed in the flywheel. That is the kinetic energy. Because we know that if any body moves with some velocity, there is a kinetic energy. So say this flywheel is also moving with angular velocity omega. So the energy will be stored in the flywheel in terms of kinetic energy, and that kinetic energy is given by half I omega square. Why? Because if you are having, say, one body, if that body is moving linearly by speed v, then I know that kinetic energy is given by half into m into v square. But in case of angular motion, m, mass, becomes moment of inertia I, and linear velocity v becomes angular velocity omega. So E is equal to half I omega square. I already we know that mk square. Substitute half into m into k square into omega square. Fine. Now, I need what? I need maximum fluctuation of energy, that is delta E. Maximum fluctuation of energy is maximum kinetic energy minus minimum kinetic energy. So, maximum kinetic energy will be half into I into omega 1 square. Why omega 1? Because omega 1 is the maximum speed. Minus half I into omega 2 square. Why omega 2? Because omega 2 is the minimum speed. So half I omega 1 square minus half I omega 2 square. Half and I common, take it out in bracket. Omega 1 square minus omega 2 square. Now this is a square minus b square. I can write it as a plus b into a minus b. So half into I into omega 1 plus omega 2 minus omega 1 minus omega 2. Now, I know. What I know, that mean angular speed omega is equal to omega 1 plus omega 2 by 2. So this expression, which expression? This is omega 1 plus omega 2.
Hello sir, ये derivation important है.
Yes, it can come in exam. This expression, fine. Omega 1 plus omega 2 by 2. I can write it as omega. See, I into omega into what is left? Omega 1 minus omega 2. Omega 1 minus omega 2. Which is equal to, now what I am doing? I am multiplying and dividing by omega. That means into, sorry, this expression. Into omega by omega. That means I omega into omega is omega square into omega 1 minus omega 2 divided by omega. So which is equal to I omega square. Now what is this omega 1 minus omega 2 by omega? This is coefficient of fluctuation of speed, because definition is maximum speed minus minimum speed divided by mean speed. That is nothing but coefficient of fluctuation of speed. So I omega square Cs. I can further write it as mass moment of inertia, that is m k square omega square Cs. So this is the expression of maximum fluctuation of energy, and which we will be requiring in numericals to solve the problem. Also I can write, what I can write, see, I know that E is equal to half I omega square. So I will be what? I will be 2 times of E. 2 times of E. So I into omega square is equal to 2 times of E. So here I omega square I can substitute as 2 times of E. So it will be 2 ECS. So this is also one formula. Now whichever formula is applicable to you, you will use that formula to solve the problem. Is it clear, this derivation? Hello?
Yes, sir.
Yes, sir.
Yeah, very easy derivation, very easy derivation. 5 marks it can come. That prove an expression for maximum speed, sorry, maximum fluctuation of energy stored in the flywheel. Clear? Okay. I think we are left with 3 minutes more. Okay.
So how much time?
3 more minutes, because in
2
this
minute
software
baki.
maximum we can record for 40 minutes. And do one thing, just after this session, there is an online test. Fine. Login time is from 1:45 p.m. to 2:20 p.m. Please give that online test for the marking your attendance.
Okay.
So you can assign another class on that.
Sorry, I can assign, but then when you will give the test?
अरे HOD सर का भी एग्जाम देना है भाई.
Here all. Fine. Okay.
जब एग्जाम होने के बाद.
Okay, let us start. Fine. Yes, one more equation comes. See, next equation. Delta E is equal to this K. This K can again be R also. This K can again be R also. If this K is equal to R, then formula will be M R square omega square Cs. We also know that this relation, which relation? Linear velocity V is equal to R omega. Fine. So I can write M into omega square. R square is nothing but V square. So M V square Cs. Clear? Next, if I want to calculate the value of mass of the flywheel, how I will calculate? I know that density rho. I know that density rho. I know that density rho is equal to mass by volume. So mass will be density into volume. See, mass is density into volume. Again, volume I can write it as area into length. Volume I can write it as area into length. Fine. What will be the length of the flywheel? Length of the flywheel is nothing but the circumferential length of the flywheel. Yes or no? Hello? Hello?
Yes, sir. Yes.
Length is nothing but the circumferential length of the flywheel. That means circumference of circle, that is nothing but equal to 2 pi r. L is equal to 2 pi r. C. L is 2 pi r into area into density. Now area of the flywheel will be, now area of the flywheel is what? Area, if I am assuming the cross section of the rim is rectangle, then area will be width into thickness, width of the rim into thickness. So area is equal to B into T. Substitute this equation over here. So mass is what? So mass is equal to 2 pi r into 2 pi r into area. This area is B into T. into density. If density is given to you in the problem, T is given, B is given, you can calculate the value of mass of the flywheel. Or if mass is given in the problem, rho is given in the problem, you can calculate what will be the area of the flywheel ring. Yes or no? Hello?
सर वीडियो अभी बंद हो जाएगा, टाइम हो गया है.
So far it is clear, whatever I have discussed.
Yes.
Yes, sir.
Fine. So next in the Friday's class, I will discuss the problem. Now do one thing, go to that IM